In every generation, humans have looked at tornadoes with a mix of awe and trepidation, posing a fundamental question: how can something composed merely of air possess such destructive power? How can it tear through houses, lift cars skyward, and then vanish as if it had never existed? And as our technological prowess has grown, enabling us to split atoms and send probes across the solar system, the question has evolved. Why, with all this capability, can we not stop a tornado? This question, far from being foolish, is born out of a natural blend of curiosity and fear. Tornadoes, with their thin, rope-like appearance, seem almost delicate. When compared to the imposing presence of mountains, the vastness of oceans, or the earth-shattering might of earthquakes, tornadoes appear weak. Many people believe that with sufficient force, intelligence, or planning, we could put an end to them. Over the years, numerous speculative solutions have been proposed. Some people have envisioned using bombs, while others have imagined deploying giant machines to redirect the air. Ideas have included planting forests to act as barriers or constructing artificial hills to disrupt the wind. Some hold hope that climate change might eliminate tornadoes, while others fear it will enhance their ferocity. To comprehend why these ideas ultimately fall short, it's crucial to first grasp a fundamental truth. A tornado is not what it appears to be. A tornado is not a tangible object. It doesn't exist independently as an entity. Rather, a tornado is a pattern formed within moving air. It emerges from a much larger system, typically a powerful thunderstorm that towers high into the atmosphere. This storm draws in warm air from the ground and propels it upward into the colder air above. Different wind speeds and directions at various altitudes create the necessary rotation. When this rotation intensifies and becomes focused near the ground, a tornado becomes visible. The funnel cloud that we see is merely the final manifestation of this complex process. It's akin to the flame of a candle. The flame appears to be a distinct entity, yet it's merely visible energy. Extinguish the flame while the gas continues to flow, and it reignites instantly. The flame was never the source. The source is the system that sustains it. This is a primary reason why humans cannot stop tornadoes. We are often tempted to confront the visible funnel, but it is not the cause. It is merely a symptom of a much larger system. The notion of using a bomb to stop a tornado is one of the oldest and most recurring ideas. People imagine detonating a massive explosion inside the funnel, hoping it will disrupt the rotation and dismantle the tornado. Some envision a shock wave, while others consider a vacuum bomb that extracts air. There are even those who contemplate the use of nuclear weapons. The concept resonates because explosions seem powerful. We know that explosions can demolish buildings, so we assume they must be mightier than wind. However, explosions and tornadoes operate in fundamentally different manners. An explosion releases energy rapidly. It is violent but transient. In contrast, a tornado is sustained continuously by air inflow into a storm. Even a colossal explosion would be fleeting, while the storm that birthed the tornado could persist for hours. If a bomb were to disrupt the funnel momentarily, the storm would simply regenerate it. The rotation would reappear, or a new tornado might form nearby. The system driving the tornado would still be operational. Moreover, an explosion would introduce additional debris into the air. Tornadoes are lethal not only due to their wind speed, but also because of the flying debris. Wood, metal, glass, and stones become deadly projectiles. A bomb wouldn't eliminate the danger, it would amplify it. Even nuclear explosions fail to address this issue. They unleash tremendous energy but do not eliminate the temperature gradients and wind patterns that fueled the storm. Furthermore, they introduce heat, potentially feeding the storm. Ultimately, bombs fail as a solution because they target the wrong enemy. They attack the symptom instead of addressing the underlying system. Upon deeper reflection, some people move away from the bomb idea and pose a more insightful question. Tornadoes require air inflow. What if we could block or redirect that air? What if we could disrupt the wind feed, causing the tornado to dissipate? This concept is closer to the truth. Tornadoes do rely on a continuous inflow of warm, moist air near the surface. Without it, they weaken. However, the inflow doesn't travel through a narrow corridor. It originates from a vast area, often spanning tens of kilometers and coming from multiple directions. The air also converges from various altitudes, not just from the surface. Air behaves differently from water striking a wall. It doesn't accumulate neatly. It flows over, around, and above obstacles. If one path is obstructed, it finds another. Redirecting it might inadvertently create new zones where winds collide. Ironically, many tornadoes form precisely where airflows intersect. These boundaries naturally produce tornadoes. By attempting to manipulate the wind, humans might unintentionally create the very conditions they seek to prevent. This is one of the most frustrating truths about weather patterns. Small interventions can lead to large, unpredictable consequences. Another seemingly clever idea involves using heat as a weapon against storms. People imagine generating artificial thermal updrafts to draw air upward and disrupt the storm. This could involve heating the ground along corridors or employing machines to produce rising columns of warm air. Initially, this sounds plausible. Tornadoes involve rising air, so if we can control that, perhaps we can control tornadoes. However, this intuition is flawed. Thunderstorms thrive on heat. Heat is their fuel. Warm air rising is precisely what storms need to gain strength. Adding heat doesn't confuse a storm, it nourishes it. By heating the ground, you increase atmospheric instability, enhancing the contrast between warm surface air and cold upper-level air. This contrast powers intense storms. Instead of weakening the system, you are fortifying it. Attempting to stop a tornado with heat is akin to trying to extinguish a fire by lighting additional matches nearby, hoping the fire will be diverted. Nature is not easily confused. Many people have observed that flat plains frequently experience tornadoes, while dense forests seem calmer. This observation has led to the idea that forests could serve as natural shields. If we planted enough trees, could we stop tornadoes from forming or weaken them before they reach populated areas? Forests do influence wind patterns near the ground. Trees increase friction, create turbulence, and alter low-level wind behavior. However, tornadoes are not solely controlled at the surface. The rotation that spawns them extends hundreds or thousands of meters above the ground. The winds of greatest consequence are far above the treetops. A forest might rise 30 meters, while a thunderstorm can tower 15 kilometers. The difference in scale is vast. Some tornadoes pass through forests without losing strength. Others may even become more chaotic due to increased turbulence. Forests are invaluable for the planet, contributing to climate stability, ecosystems, and flood management. But they cannot eliminate the atmospheric ingredients that spawn tornadoes. Forests may alter the damage pattern, but they don't determine whether the storm occurs. Observations also suggest that tornadoes are more prevalent in flat regions than in mountainous areas. This has given rise to another idea. If mountains reduce tornado occurrences, why not construct hills or artificial mountains to protect vulnerable regions? Mountains do influence weather, but not in a straightforward protective manner. Small hills are ineffective against storms as air easily flows over them. Terrain can also channel winds through valleys and passes, potentially increasing wind speed and rotation. Some severe windstorms become more powerful in mountainous terrain due to concentrated airflow. Constructing hills in unsuitable locations could exacerbate local conditions rather than improve them. To significantly influence tornado-producing storms, the terrain would need to be vast, stretching hundreds of kilometers, and soaring to great heights. At such a scale, humans wouldn't merely be protecting cities, they would be reshaping continents. There exists a persistent myth that tornadoes are an exclusively American problem and that they do not occur in southern Europe. This belief, while comforting, is inaccurate. Tornadoes do occur in southern Europe. Waterspouts frequently form in the Mediterranean Sea, occasionally moving onshore and transforming into tornadoes. Countries such as Italy, Greece, Spain, the Balkans, and Turkey have all experienced damaging tornadoes. While they may be less frequent and typically weaker than the most severe tornadoes in the United States, they do exist. The risk is often underestimated due to lower public awareness and limited historical documentation. Nature pays no heed to borders or assumptions. When climate change is introduced into the discussion, emotions often run high. Some hope that a warmer planet might reduce tornado occurrences, while others fear it will render them unstoppable. The reality is more complex. Tornadoes require two primary ingredients: energy and wind shear. Energy comes from warm, moist air, while wind shear arises from differences in wind speed and direction with height. Climate change undeniably increases energy. Warmer air holds more moisture, and more moisture means more potent storms. This aspect is well understood and supported by scientific evidence. Wind shear, however, is more intricate. Some large-scale wind patterns may weaken in certain regions as temperature differentials shift, potentially reducing some classic storm setups. But tornadoes don't require perfect conditions. They need sufficient conditions. Climate change increases the number of days with adequate energy combined with sufficient wind shear. It also alters the timing and location of these conditions. Instead of more tornadoes everywhere, we witness increased unpredictability. Tornado seasons shift, nighttime tornadoes become more common, and outbreaks become more clustered. When storms do organize, they can be more intense. Climate change does not eliminate tornadoes. It modifies their behavior and amplifies risk in subtle yet perilous ways. When all these ideas are considered together, a simple truth emerges. Humans attempt to solve the tornado problem on a local scale, but tornadoes are generated on a regional scale. Our tools are designed for buildings, machines, and landscapes measured in meters or kilometers. Tornado-producing storms are governed by atmospheric layers thousands of meters deep and weather systems spanning hundreds of kilometers. The energy driving these systems comes from the sun and the Earth's rotation. Humans cannot compete with such energy. We can only adapt. Weather systems are inherently chaotic. Small changes can have negligible effects or trigger massive unintended consequences. There is no safe way to fine-tune a thunderstorm in real time. This is not a failure of human intelligence. It is an acknowledgement of our limitations. Since we cannot stop tornadoes, humans have adopted a more effective approach. Preparation. Early warning systems detect storms before tornadoes form. Radar technology identifies rotation before it reaches the ground. Forecast models improve each year. Shelters save lives, stronger buildings mitigate damage, and education empowers people to act swiftly. These solutions may not be dramatic or resemble humans battling the sky, but they are effective. Tornadoes cannot be halted because they are not adversaries to be vanquished. They are manifestations of how the atmosphere redistributes energy. Forests, hills, bombs, heat, machines, and barriers all fail for the same reason. They attempt to control a global system with local tools. The future does not lie in stopping tornadoes, it lies in understanding them earlier, respecting their might, and constructing a world capable of withstanding them. This is not a concession, it is wisdom.